Welcome to Study Loop.
Okay, so this is a question about the heat of furan. So it actually gives the heat of furan is water, and it didn't give the temperature, but we already know that for water, it actually melts at 0 degrees C. So we actually can write down that at 0 degrees C, the heat of the furan is actually basically the water, which is the solid phase, at 0 degrees C and forms the water as a liquid phase, but also at 0 degrees C. And we know the heat of furan given here, we use HF1 to indicate equals to minus this is not minus, right? It's actually 6.02 kilojoule per mole. I don't think there's a minus sign because for water to become liquid water, it actually is a endothermic reaction. So the heat furan should be a positive sign. And also, this question asks us to calculate the heat of furan of water at -degrees C. So we can also write down the reactions. It's a solid phase at -degrees C and converts into the water liquid phase and -10 degrees C. And actually wants us to calculate the heat of furan. How can we do that? So you can see for both states, the water solid phase decreased the temperature, and liquid phase also decreased the temperature. So then we can actually make two artificial equations. So let's just write down this as equation 1 and equation 2. How about equation 3? Right, when we have water from S equal to 0 degrees C becomes a solid water, but becomes -degrees C. What's the energy? This part of energy, H3, is actually simply equals to the heat capacity of the solid because this is per mole, so we don't have to use mass or more, and times the change of the temperature, which is -10 degrees C. So we can just do the calculation. The heat capacity is 37.7 joule per mole per K, and times the minus K. And this equals to 377 joule per mole, and it's minus sign. And a fourth equation is basically the liquid 0 degrees C. When you cool down the temperature, it becomes liquid phase still, but becomes -degrees C, 10 degrees C. What's the energy involved? It actually is heat capacity times the change of temperature. So the heat capacity here is 75.2 joule per mole per K times -10 K. And this equals to 752 joule per mole, and has a minus sign. And look at here, you will find actually the equation 2 is simply equals to the equation 1 over minus equilibrium 3 and minus and plus the equilibrium 4. So you know that equilibrium 2, which was what we want, equals to equilibrium 1 minus equilibrium 3 and plus equilibrium 4. So delta H2, which F2, is simply equals to delta HF1 minus delta H3 plus delta H4. So what I need to do is just plug in the numbers here. So 1 is 6 kilojoule per mole, so 6,000 joule. And minus delta H3 minus 377, and plus minus 752. And we can actually do the calculations now. It's around 5.627 kilojoule per mole. And this is the heat of fusion for the water at -degree C. And this is the answer.